Good afternoon. This is Nishant, and this is my internal assessment project for relational database management system. Okay. So my topic selected is practical application and evaluation of NoSQL databases in cloud computing. This paper was published in 2012 in the IEEE International Systems Conference, SysCon 2012. Okay. Yeah. So the growth of the internet has resulted in massive volumes of data. The information is contaminated, it is fragmented into pieces and of many types. Organizations and companies are exploring beyond the standard data warehouse solutions and into the big data technologies, such as NoSQL data systems, as a result of increased data creation. The goal of this thesis is to provide a comprehensive review of certain non-relational databases, understanding the many NoSQL databases that are relevant, examining their benefits and drawbacks, explore the system that use NoSQL databases, and define the data model and architecture. We will also select the best models for designing an app that tracks a keyword across numerous social media networks. Methodology of the project. So the types of data models here are key values stores, document-oriented data stores, big table clones, graph databases. So moving to key value database. So here you can see the various keys. Those are the user 1, user 2, user 3, user 4, and its value, user 1, and the details of each user. They are mapped to each other. Key values. So basically, key value stores are the NoSQL structures that more closely resemble meme-cached system architectures. They are largely responsible for mapping keys to values. Adds, reads, and delete data to the store using atomic operations. Advantages of key value stores would be among all the data stores, this data model is the simplest. And also they have the ability to scale horizontally. The disadvantages would be it is far too simple to be used exclusively in complicated problems, and they also add replication and redundancy. You have a few examples: Project Voldemort, Tokyo Cabinet, Redis. Document-oriented data source. So as you can see, you have a document-oriented database here. It's couch-based data. It stores metadata with each key value pair, and it is unique and kept in the RAM, and the document value is most recent in RAM and persisted to the disk. Yeah. Okay. Methodology of documented oriented data stores. The querying of documented oriented data stores isn't restricted to just one key. Okay. It has several advantages. It's a well-balanced solution that bridges gaps between the two extremes, that is key value stores and big table clones. This very small scale applications are possible using document-oriented databases. Disadvantage would be document databases lack the relational capability of relational databases. Also, with high-level networks, they aren't that well adapted to data volumes. Examples are MongoDB and CouchDB. Big table clones, so you have clients, you have connected to front-end server pool, connected to a node, connected to SS table, and connected to shared log. Big table clones, they have the most comprehensive data model. Advantages would be in terms of number of columns in each row and overall number of rows, they are more scalable. Big table's most significant flaw is its lack of relational database capabilities. Examples would be Cassandra and HBase. Graph database. So you have a graph here in which every entity is connected to relations. So yeah. It's similar to document-oriented data models, but graph databases feature relationships between nodes in addition to document-oriented. When relationships are more important than nodes of data, graph databases are employed. Different abstractions exist in graph data stores. Graph databases employ nodes, relationships, and key value properties instead of tables, rows, and columns. Advantages would be in web apps. This is used in web apps where relationships are more crucial. It's a perfect fit there. Disadvantages would be it adds to the database structure, resulting in additional complexities. Example would be Neo4j. Case studies. Now we'll delve further into certain models to find the best database for designing an app that follows a keyword across numerous social media networks. First would be cloud virtual machines. The system infrastructure was established upon Amazon machines. The clusters were built using Amazon's EC2 services. AWS will offer Zen-based virtual machines, and to make clusters, we use Vir. Redis case study. Redis is a key value store that runs in memory and is not persistent on disk. Instead of bare values, it supports fundamental data structures. Redis has a master-slave replication technique and keeps periodic snapshots. Redis also allows transactions and creation of a pub/sub master client. We can use Redis to store messages traveling through our system because it's highly quick. You can see the architecture here. You have clients, then you have an app, you have MySQL database, you have Redis replica, and you have Redis master. Okay. Now you have Cassandra. Apache Cassandra is a distributed database that is extremely scalable. A single table, which is a multidimensional map, is normally included in a Cassandra instance. Inserting, retrieving, and deleting data are as simple as they are in a key value storage. A key identifies each row, and actions on rows are atomic. Columns store numerous values, but not all of the columns in a column family values. Multiple columns can be connected with super columns. So as you can see here, there's Apache Cassandra, the NoSQL distributed database. You have a data center ring, and then you have nodes all around it. And the communication is gossiping. MongoDB. MongoDB is one of the most popular frameworks till now. MongoDB and relational databases have following relationships. The concept of a database hasn't changed. The indices can also be created in MongoDB. In MongoDB, the concept of a table is referred to as a collection. Advantages of MongoDB: it provides you with working with SQL-like queries and avoiding the issue, avoiding the use of map and reduce. There's a lot of documentation and a huge community of people who use MongoDB. There are drivers for practically every programming language. So you see how universal it is. And the installation is also simple. Conclusion of the project. The goal of this study was to provide an overview of the various NoSQL data stores that are currently accessible. The case for adopting NoSQL database systems in architecture that need to scale out, as well as a detailed look at the model which we found suitable for a particular online application. It is impossible to get consistency, availability, and partitioning all at the same time. A system is consistent if it either works completely or not at all. The ability of a database to function even if a node in the cluster crashes or some hardware software fails is known as its availability. Even if the data is partitioned amongst different servers, partition tolerant systems have the same properties. We also chose MongoDB due to its consistency, partitioning, and we dropped availability. Future work: to function correctly, the system requires numerous modifications. The team plans to increase the overall system speed in addition to establishing a web interface. Making batch inserts in the database instead of simple inserts is another improvement. As a result, the database performance will improve, allowing it to handle more queries and process more data. Currently, the system simply collects Twitter and Facebook mentions with a significant delay from the real streams. The team will increase processing and design and a queuing system to handle these messages in order to improve the situation. A rapid in-memory caching solution such as Redis can be used to store the queues. This is the bibliography for the data for the research paper. And thank you, everybody. Thank you for listening.